Okay, so now we're gonna solve this beautiful absolute value equation here. This is the absolute value of x minus 3 equals 7. Okay, so reasoning from analogy, we're gonna proceed to the solution of this problem. We know that there are only two possibilities for the inside. Either the inside is positive or the inside is negative. Okay, so so if the inside, if x minus 3 is greater than or equal to 0, or x minus 3 is less than 0. These are the two possibilities, right? Okay. Okay. So if the inside is positive, then how does it come out of the absolute value? It just comes out without the absolute value bars. Then x minus 3 is actually equal to 7, okay? Because if x minus 3 is, so again, recall. So here, the absolute value of x is equal to, it's equal to x if x is greater than or equal to 0, or it's equal to the opposite of x if x is less than 0. So what I want you to realize here is I'm kind of making like a little table with two columns where I'm taking care of both of these cases. So if the inside is already positive, if this inside is already positive, then it must itself be equal to 7. What if the inside is not positive? In other words, what if the inside is negative? Then how does it come out of the absolute value? As the opposite. So we get negative, open parentheses, x minus 3, close parentheses, must equal to 7. Right? So let me just recap, and let me show you exactly how I'm using the analytical definition. Remember what the analytical definition says. The absolute value of some number x is equal to x if x is positive or 0, and it's equal to the opposite of x if x is less than 0. Looking at this particular example, either the inside is already positive, right, like this, in which case the absolute value of that number is just that number, or the inside is negative, in which case, if x is negative, the opposite of x comes out of the opposite of x is what comes out of the absolute value. So here, what comes out of the absolute value? The opposite. And since it equals 7 in both cases. Now what happens in this case? In this case, to get this x by itself, to solve for the x in this linear equation, I need to add 3. Okay, whatever I do to one side of the equation, I do to the other. Here, the negative 3 plus 3, that goes away. I'm left with on the left-hand side just x, and on the right-hand side, 7 plus 3, that's 10. Okay. What about over here? Now, I can solve this equation in one of two ways, okay? So one way I could do it is, I could divide both sides by negative 1. I'm going to divide by negative 1. I'm going to divide by negative 1. Why am I dividing by negative 1? Because this expression here, negative x minus 3, is the same thing as negative 1 times x minus 3, okay? They mean the same thing. Let me make that note as a remark here. Okay. Okay, so negative absolute value, negative open parentheses, x minus 3 is the same thing as saying negative 1 times x minus 3, okay? And so if I wanna counteract the multiplication by negative 1, I divide by negative 1. And in other words, if you look at it here, you'll see if I'm dividing this expression by negative 1, this negative 1 on top and the negative 1 on the bottom cancel out, okay? And so on this left-hand side, we're left with positive x minus 3 equals, and what is 7 divided by negative 1? 7 divided by negative 1 is negative 7. First of all, because a positive divided by negative is a negative. And second of all, because 7 divided by 1 is 7. So if I have positive 7 divided by negative 1, that's negative 7, okay? Okay. Now, how do I get the x by itself here? Here, I'm having x, and I'm subtracting 3 from that x. How do I counteract that? How do I do the opposite? I add 3 to that x. So I add 3 here, and I add 3 here. Okay? Negative 3 plus 3, 0. So I bring the x down. X equals, what's negative 7 plus 3? That's negative 4. Okay? Okay? Why is it negative 4? Because if I look at these two integers, the negative 7 and the positive 3, the negative 7 has the bigger absolute value. So the result will be negative. Now, how do I get the actual value? Well, I take the absolute value of the bigger one, and I subtract the absolute value of the smaller one. In this case, it just happens that the absolute value of the bigger one is 7. The absolute value of the smaller one is 3. So I subtract them, and I get 4, okay? Okay. So let me just recap there a little bit, just to restate anything that I might. So just to recap really quickly, because I might have said something that didn't capture exactly the right thing. So, but I just want to recap it. So here I have negative 7 plus 3. The sign comes from the integer that has the bigger absolute value. What is the absolute value of negative 7? 7. What is the absolute value of 3? 3. Which one has the bigger absolute value? The negative 7, which has absolute value 7. Therefore, the sign of the result of this addition of numbers with different signs will be negative. What about the value 4? Whenever we're adding two integers of opposite signs, the value, okay, once we've determined what the sign will be, as we just did, it's negative here, the value will be the difference of the absolute values of the numbers being added or subtracted, basically, but where the absolute value of the where the integer with the smaller absolute value, where the absolute value of the integer with the smaller absolute value is subtracted from the absolute value of the larger one, okay? Anyway, we'll see more examples and you'll see what I'm saying. In any case, you can see here our solution set is x equals 10 and x equals negative 4. Now we're going to be really careful here because we want to verify that this in fact works. Look at 10. What is 10 minus 3? It's 7. What's the absolute value of 7? 7. What about negative 4? Negative 4 minus 3? That's negative 7. What's the absolute value of negative 7? 7. So we now know our solution is right. I also want to point out something else to you here. This is very important, and we're going to see it. We're going to see that this is very helpful in seeing what's going on here. If I look at this value 3, okay, and I go 7 to the right, 1, 2, 3, 4, 5, 6, 7, and I go 7 to the left, 1, 2, 3, 4, 5, 6, 7, and I label these with numbers. So this will be 4, 5, 6, 7, 8, 9, 10. This will be 2, 1, 0, negative 1, negative 2, negative 3, negative 4. You'll see that what happened here is that the solution of this equation represents those numbers that are 7 away from the 3. Okay? And so in this case, you can see that if I graph this on a number line, the x minus 3 equals 7 is an interval where the opposite of this number was the center and where the distance to the two solutions was 7. Okay? Okay. Anyway, I hope you all have enjoyed this example, and I'll see you again in a few moments. Thank you.